Hooves gives you personalized beauty advice based on what works with your unique facial features.
If you struggle with focus, this sound might change everything.
So we turned back to the console. You know he's not playing up about 20 minutes. You end up looking the same as. Okay. Okay, so your dog was this console. So let's play with it. He has 10 distinct strings. Cool like one. He wants to spice some.
For procurement managers, Grainger is the go-to partner that helps keep your healthcare facilities ready for patients. Because there's no time to manage orders and deliveries from multiple suppliers, Grainger offers everything in one place, from disinfectants to lighting, air filters, and more. All with fast delivery that helps ensure you always have what you need to put patient care first.
It's called natural selection. They just mess it up. So, I want to know about this concept so much. What's your favorite gift? Do you guys like shrooms? Stars. Alright, let's play with it. Entering strings of equal like m. You have to describe some of the strings possibly and reorder them. Reorder the remaining strings. So the concatenation becomes palindrome. Okay, so you want to delete like okay, I see. This one kind of seems he wants to keep the palindrome as long as possible. And he wants to delete such that we can make it to palindrome. Okay, so this one is kind of a tricky problem. So the idea I'm kind of having at the moment is I guess the first thing we can kind of do right now is construct the load prefix. All right, that's a problem. A palindrome is simply a string where basically the reverse of it is the same as a string 2. That's practically it. So we have m strings of length, I guess length m, and of length m. This is true. Now, for this, so for it to be a palindrome, we know that this has to be true. We know that for a string, if it's even, every single string has to be, what is it? S, I is equal to S, I believe the length of the string, let's just call the length of the string M. I believe I. So, like tab, have that. And let's 0 index it, and M equals 1. Or, actually, yeah, let's just say that the length of the string is it's not M, but it's M. Basically, the length of here, whatever it is. I'll just call it M, just to make it simpler. M minus 1. So here is simply just matching here, here, this B. So again, my idea is, well, sorry, I'm kind of talking all over the place and not really making coherent arguments. So I want to kind of determine, I suppose, is there like a way to pick out certain strings such that so like let's say like for instance tab tab 1 and then that right here. Oops. Like tab. I think also remember that we're deleting a string as well too. So output is 6 and then tab, yeah. It's like for instance here, it's how do we determine this like string selection? So we have tab and then we have one and then we have out. So the first thing we have to kind of ascertain is the selection of string. So for this test case, the first one is just tab one and out. Notice that tab and bat both have the same they both have the same characters. So we know that that's possible for the most part. So if let's say like we have like a pair of characters for the most part, like yeah, like a pair. So two characters where they're both equal, then obviously if we conjoin them. Wait, I'm not. That might not be. Wait, I might. Hang up now. Let me go back to the computer because I think we can still because again the same characters could be completely different. So like for instance, tab, although they have the same characters, is not necessarily true. If that makes sense. Like tab, it would never form a palindrome. But yeah, notice that tab and then bat both have the same characters, and if you concatenate them, then yeah. But one doesn't really have a. And since we want the longest one too, so I'm just gonna look. Let's do several test cases right now. So tab one out. Yeah, so we know that one. So we know O X X O X X. So looking at this right here, we have So this is a. I mean, just making observations. We can get. Oh no, we can't. It doesn't look like you're gonna use XX here, maybe, because maybe you can use OO and then OX here and then XO here, but that's about it. Just six. You can't really use XX here. At least for that's my observation. And I guess my question is, what did I do here? Well, I kind of let's see. Since we could also do XX by the way, and then here XO, and then what was it here? I believe XO, yeah. It's the same thing. But I guess what I did basically here is first saw this OO, and I think yeah I kind of ascertained we can put in the middle since they're it's a palindrome in of itself, and um now notice that there's like there's okay, so it's a big hint. There's 100. There's only like up to 1,000, sorry, 100 characters, and m can be 50. So it's like basically n times m is 100 times 50, which is relatively low, 5,000. It's 5,000, so like you can probably do n squared if possible. So third test case, hello, code,
Are you the kind of person who knows things? Things like you can get a domain from Squarespace, not just a website?
yeah, here I don't think we can do any kind of and I don't see no type of palindrome possible because Because there's no way we can kind of configure one. Um, as far as that goes, so what is my algorithm here? And the algorithm should kind of work for this case. I'm just gonna use this example right here to kind of first look at a character. I guess if it's a palindrome, you can put it in the middle. And then here, I guess you kind of check if this works. Again, there's no structure for this one. Alright, I'm just kind of just talking out of my ass now. I'm just gonna, I'm gonna calm down. Let's kind of figure out the strategy here. Sorry, I'm still thinking how to solve this. syndrome, which I guess you can say the longest will be obviously m times n. I mean, they kind of got to deduce, so we know that that's a length. So we're given we're given n strings, each of length m. Okay, so we know that for sure. I guess one thing we can prove is does the length or the answer matters whether m or is it the length of the strings, is it even does it influence anything? So let's make an assumption that it does mean something. sorry, I'm kind of I'm just kind of lost. I'm literally just sitting down and just daydreaming. It happens a lot. I kind of do wonder sometimes, how do I even get myself like to stop doing this? Be active. I should. I guess it's procrastinating. Okay, so it seems like I have it kind of a hint. So I guess what we can kind of do, I suppose, is there's only two variations of palindrome we can kind of ascertain basically. one where like there's a palindrome in the middle. So in our answer, the palindrome is kind of in the middle first. So let's just hypothetically say with like a some palindrome. I guess I'll call it P, and then afterwards, here, whatever this string is. Wait, sorry, is it showing? Yeah, whatever is here basically is going to have some string s and t, where s plus t is a palindrome. Basically, yeah. Either it's s plus t or s plus p plus t, where p is a palindrome. I guess the question now comes down to p. I guess p doesn't necessarily matter. We can pick the big. So like p would never be like in front or behind. It's not possible. So I guess the question now comes down to how do we and I guess the length of p also as well doesn't really matter. So I guess the question now comes down to how do we ascertain s or t? Because s, I believe, again, remember s plus t is so I guess the first thing is to kind of get the longest palindrome p. So out of the list of strings, get the longest palindrome p. And then now we need to kind of ascertain s now. Sorry, s and t. Um, so to get s and t, I believe, I guess right here is a really good example. This weird one where A B W X Y Z I J J I Z Y X. So this M is 4, so every single character here is 4. This right here is P, and then all of this is S right here. Now, and all this is T. Now notice that W, Y, X, Z, and then Z, Y, X, W. This could be S, and this could be T. Note, and also note that this here as well. A, B, and then B, A. This is also S and T. So you can add these two together such that um, we can get a longer palindrome. Okay, so with that being said, and also, so we can only have one P though. There's a base. Okay, so I'm not gonna worry about there's about this is just case one where. So I guess case one is S plus T. Case two, it's S plus P plus T. And then case three, I believe it's just P or PK, or like K is an integer. Basically, we can have like multiple, it's like multiple P's in a sense. So we can have like 4 or 5 P's, and like obviously concatenating all, like let's say we have ABBA, we have like 7 of them. Wait, would that even be a palindrome? Okay, let's say we have 6 of them, right? Let me see. Would this be a palindrome? I believe it would. I believe it would be, right? So okay, so A B A. Okay, this would be a palindrome, and also I believe if we were to add one at the end too, it'd still be a palindrome, right? Because like we A B A A B B. Yeah, and I'm guessing it would be the same with A B A B. That's me, right? No, it would, okay, actually it wouldn't. Okay, so it would only work if it's odd. No, no, this even no, not even this would be a palindrome. So this would be classified as P. So let's give it a, I guess B A A B, right? This is a palindrome. So A. Is this a palindrome? So right here, A B B B B A A. Okay, so it doesn't matter what the length of the P is, as long as P and the K is integer. So we have 3 cases basically. So case one, I'm guessing case one, or let's put case one in a sense, finding S and T. So finding S and T involves finding two S and T such that S plus T is a palindrome. Um, since n is, I believe, since n is 100, we can simply just do a for loop and see if it exists. So basically, like, just check if S plus T is a palindrome. If it is, so we can kind of like what's it called, nested loop this everything. Yeah, okay, so we can kind of find S and T. Now, let's case two where we can find P as well. Case two, right? Case two where we look S plus P plus T. We know how to find S and T. It's just simply it's like a variation of case one, but to find P base, to find the longest P is simply just looping through the list of numbers and finding the longest palindrome. Now the last one is simply just P times K. Again, this one is okay. So this one is more convoluted because there could be like the longest palindrome, so like a palindrome with that is so like palindrome P1 that is greater than P2, but P1 P2 times, I guess, K2. Let's say K2 is the I guess the number of there could be cases like this, which will be hard to kind of solve. So in this case, we kind of have to, I suppose, every single string that's a palindrome. We gotta find like every palindrome possible in the list of every palindrome possible, and then I suppose get the frequency of it, and just kind of we need to kind of get the longest one. That's kind of how it works. I guess for this problem, it seems that how do we determine which case it is? That's a really good question. So like S plus T, S plus P plus T. Obviously, if we have S plus P plus T, S plus P plus T is obviously going to be greater than S plus T because obviously we're adding another. So, um, in this, like, obviously, if we pick two, we're obviously going to pick this case. That's for certain. But I guess the first thing we should probably do is look for all palindrome. We're gonna first do this, right? First do this, like P plus K here.
break is brought to you by
So the
Injectable
algorithm here, I
Cabenuva.
suppose,
Cabotegravir
very
ropinirole.
first thing I'll probably
Your
do
feel
is
good
like,
playlist is always there for you when
let's
you've
just
got
kind
to
of make
hype
our
yourself up. So
first, I
take
guess,
this
get
time to
like just
boost
maybe
your
get a
day and
frequency.
get a little break from whatever you're up to.
So like, let's say we have like is palindrome, whatever, right? For all strings, for all strings, right?
And did you know that an injectable treatment could also be there for you? Get the facts on
And
Cabenuva
okay, so
at
if it is,
cabenuva.com.
basically we're gonna get the longest palindrome equals to, I guess, S. Obviously, it's S is gonna be the string. I guess string S. S times frequency of S. This is just simply we're gonna do this to all. So remember, if S is a palindrome, we're gonna get the longest, the frequency of S too. That's it. This is case three. Case three, and then for the rest of the case, we're gonna use the rest. So we're gonna keep this in. And I guess now that I kind of thought about it for a second, you know, couldn't we just kind of do S plus P times K plus T? So is it so? What the fuck? I don't know how to not think about that. So just look for S and T. S plus T. Okay, this problem seems to be not okay. This is gonna be a simple problem actually. Um, so what we can do here is so I guess we can separate by so P and an NP is non-palindrome. So we can say bool is palindrome. Then it's a string S, and then if okay, so now I got that kind of settled. So just loop through all the okay. So now this is gonna be a issue. So I guess obviously this one is just making sure that string and then or actually int and then string, right? So what I'm gonna do is just loop through what we're gonna do now is just np I believe si. Okay, it's correct, I suppose. Wait, no, it's not correct, is it? So, this is simply just getting the longest palindrome. The fuck? So, remember all these are palindromes, right? So what we're gonna do is basically get the. Wait, we need to know the, I believe, the character itself. We need to kind of ascertain the character too. I forgot. So I guess no, we can call it string longest p. Oh, so it okay returns no value. Okay, so s and then just. So here, what we can kind of do here is whoops, longest p here. Wait, why is this wrong? What's wrong here? Is it all? What's the string though? Well, if it works, it works. Okay, so we need to get the longest palindrome here. I guess now the question is how do we solve this now? There's multiple ways of doing this, to be fair with you. I guess I'm trying to look for the easiest way, really. Um,
Myself 10 years from now. It's so far away, it's almost impossible to imagine.
but I guess I can just do this. It's a really tedious way, but
Wonderful person.
it gets the job done, I guess.
Wonderful person. Always be cheerful.
So what we're gonna do here is, I suppose, we're gonna loop through all elements of A. So AI.se. So fi. That's a string. If the string times the number, actually, just to make it less confusing, so the size of the string times the, I mean, to be fair, isn't every single string just n? It's just m, right? I believe. So I'm just gonna pass in. Yeah, it's just m, right? So if there's five, or t, every single string size is m. So there's no bigger or smaller string. All string sizes are the same. So I guess this is just more so tedious, right? So we just kind of need to count the frequency first. Count the frequency of all of those. So after we count the frequency of it, we just gotta count which frequency is the max. So you get the, I guess to get the max frequency, which one has the max frequency? Which index, essentially? Hold on. Wait, let me see for a second. So let's say we're looping through every single, let's say index. Uh, I is why I kinda hate this. Right. So we have A. Let's just say we have like 5 of them, right? And then B. We have 3. So let's say like obviously this is 5 by 3, right? We get the. We're gonna store this, and we're also gonna point that to index. So we're gonna store the max first.
I have lost all hope. Is it even worth it anymore?
And after we do that, what we can do now is just construct the. We're just gonna add it. Oh yeah, this is I believe Fi, and that should be our. That should give us our. Oh yeah. It should be. Oh, is that P's are defined here. So non palindromic now. This one's gonna be kind of a hard thing to do because you know- okay, okay. So good. All right. So I missed this part. Apparently, it's distinct. So all of them are distinct. There's no two are the same, which I suppose we just kind of wasted so much fucking time here. So there can only be one P. So it's just like a waste of fucking time. So if they're distinct, that means we can just do Okay, so A B A B and then B A B A. This is a palindrome, right? Is B A B A A B? Okay, so these two are palindromes. Okay, all right. So the for loop will not work at all. Or because you don't fuck, it's gonna be or we got to remove it afterwards because like we're just gonna add them twice. I guess we can just just keep like a bool tracker. Whatever. I can just call it whatever, right? What we can do is, okay, so string first, and then 0 because, or you can just put false to make things simpler. Oops. So what we can do here, okay, so ouch. Wow, such a fucking weird problem, bro. I hate it, but I love it. Oh, yo, it actually fucking works. No way. Okay, it seems that I got it working now. Since this one works. Wow. I'm surprised I got it to work though. I'll be honest. I was kind of I kind of doubted myself, but it works. So let's try it and see if it has test cases. Okay. In these situations, if I did fail like a test case, I would probably hate myself because I didn't really calculate time complexity. It could be like really like a lot. Okay, seems like cord push is down, so I gotta wait for it to pop up now. seems to be down, so I'll just wait and try to do some other stuff now. It seems to start working now. I'm passing like a bunch of them, so I'm assuming it's gonna work, but you never know. But yeah, here's a live action. I'm probably gonna do a different problem. Depends. I couldn't tell you. All right, that's actually pretty good. I got one problem correct. So I'll just do some other stuff for a little bit, and I'll go back. I'll jump back to CF again.